So we will start with the most obvious basic questions, right? What's a software? So what's a software? I mean, you already know the answer. It's basically a set of programs which work together in order to solve a problem that you experience, right? The user experience. Right? We all use a lot of software at our day-to-day work, right? Day-to-day work or day-to-day activity. We use a lot of software. And by the way, currently I am using the Google Slide and I am using GoToMeeting. Then I'm using Google Chrome to use on the Google Drive access. Then apart from that, right, I'm going to use a bunch of software so that I can draw and demonstrate certain things to you. I'm going to use many other software on a day-to-day basis, and while we speak, I'm using a bunch of them already. So what this software does is this software helps me to do something or to accomplish something. For example, the Google Slide helps me track the daily topics what I am going to cover in this training, and then I have also the ability to share this with you all so that you can also keep track of the daily topic list what we are planning to cover and what we covered so far. And then I have basically Google Chrome that allows me to access the websites, including docs.google.com, which is a website that I access in order to access this Google Slide software. And then apart from that, I would also be using tools such as some drawing tools that allows me to demonstrate what I am explaining in a more a picturization manner, right? All those things that can be done, right? Then right, these are various options which I currently have. And and uh, so what I'm trying to say is we use a lot of software at our day-to-day work, and we are using them because they are solving certain problems. And maybe any of you are using any paid software, right? It is also very much possible that you are using a paid software. You are paying money to use the software, which is obviously, it means if you are paying for something, it definitely means it is helping you a lot in one way or another, right? That is the important part. And like that, so basically a software is a set of program and they work together in order to solve a problem that the user is experiencing. And that is very very important. The software, every software that you develop should solve a certain problem that your user is experiencing, or it will help your usage in some way. That's why the companies develop software, right? No software will have a future if it is not user favorite, right? Always when you develop a software, you develop the software to help somebody, and that somebody is should be satisfied with your software, and that determine the future success of your software or the future popularity of your software. So every company or every business, when they develop a software, this is what they have in mind, right? They are developing the software to help the customer or to but I mean, not just to help the customer. At the end, what they need is to grow their business, right? Increase the number of customer, and also increase the revenue, right? These are the main uh, important activities of any business. That's what they want to do, and they want a software that is in align with their business, right? For example, think about Amazon. They have Amazon.in or Amazon.com, right? You go there and you buy various product, right? You have the ability to buy the things rather than going to a shop. You can order the items online, and then Amazon provide all those facilities that helps you purchase the items, right? Of course, that's building the website is not their business. Their business is to sell and get some revenue, or provide a platform for the people who want to sell the item and people who want to buy the item, right? So the Amazon connect sellers and buyers together, so that the seller can sell the item through Amazon and the buyers can buy the item through Amazon, and then Amazon make a commission every time they a order is placed, or every time item is shipped, right? Amazon makes some money every time this happens. So that's what they do, and that's their business. And then there are various department in their company who uses the software as well. The support department uses to track all the customer queries and then follow up with those customer queries and then checking the status of what is going on, right? All those things can be tracked by using some kind of a supporting system software, which is an integral part of any company. And then apart from that, there would be inventories that the Amazon company need to maintain and manage. Batch of go down where they want to put the items in and take the items out, and then whatever items that are there in the inventory, they should track them down, right? There should be a proper tracking mechanism, computer based tracking mechanism, and for that they need softwares. And like that, what I'm trying to say is there would be a lot of user who would be using the software, and then software would satisfy every person's business requirement, right? Everyone work should be supported, and that's how a company should develop a software. It's important that whatever software that you develop, it is aligned with your business, right? So that you can make some business and you can make some revenue out of it. It's an important part of any software. So that's what it is, and it's a set of program. And in order to maintain and manage a software, you need a team of developer who do the coding. You need a quality team who will test the quality of the code that the developer have developed, and then you need operation team who will run the software in the cloud or in some infrastructure, right? They are knowledgeable about the network, they are knowledgeable about the machine. So you need an operation team who will maintain and manage the applications running on the cloud or some infrastructure. You need security team who will ensure the security of this particular software. So there would be a bunch of team inside the company who will be maintaining and managing the software. So it is important that you have a strong team and a strong strategy, and there should be a strong process that the company need to maintain and manage in order to achieve a proper software development, right? And delivery of that software to the customer. And most of the time softwares are already present, and as a company your responsibility is to maintain and manage that software. I wouldn't say maintain, I would say develop that software further. Basically keep on adding more and more features to the software, and whatever feature that become invalid, just remove them, and right, then keep your software simple and fresh, and then add the new feature that today's market demands, right? Remove those feature that you don't need anymore. So basically you keep developing the software as long as your company is in the business. So that software development process never stop, right? As long as your company is in the business, the process will never stop, right? That's important. So that's what it's all about. So that's what a software is, and right, that's the whole point of a software. And then what is a web application? Web application is a software that is based out on web, right? Google.com or docs.google.com or drive.google.com, right? All these are web-based software. The software that can browse using some HTTP client. In my particular case, it's a browser. Using a browser, I can access a website and then I can see the website. Amazon.in is another example, right? Basically, you use those software just like the software as accessible to you in front of your computer. But the truth is that, I mean, the softwares are not completely running on your laptop. These softwares are actually running on some HTTP server sitting somewhere on the internet, maybe in Mumbai or in Hyderabad, right? In a place that is far from you, or maybe sometimes in outside India, right? This software is potentially running on some machines in the cloud or some machines sitting in a remote data center, and then using my browser I am connecting to that software, and then a part of the software would start to run on my laptop also. Basically the front end of that software would run on my browser, and I can interact to the software by clicking some button. When I want to log in, I can click on this login button, or when I want to purchase an order, I can select the item, I can add it to the shopping cart. I have all these functionality that I get as soon as I browse for this particular URL. So basically, right, web applications are one of the most popular softwares in the world that you can access uh, just using an HTTP client such as a browser. So that's that kind of software. We call them web applications, and usually this is how it works. You have a client, right, which means typically a browser or something, right? Assume this is your laptop, or you open your browser, you browse for google.com or amazon.com. Then there are some server, maybe one server or multiple, right? There are some servers sitting somewhere on the internet. Maybe this server is physically located in Mumbai, or it's in Hyderabad, right? And then from your laptop, you establish a connection to that particular machine from your laptop. So maybe you are sitting in Bangalore, doesn't matter, right? You browse amazon.com. As long as you are connected to internet, it works for you, right? You have the ability to speak to the machines that host the Amazon website, and then that machine will respond to your browser, and that is when you get the Amazon web page, right? That's how things works. And most of the time, it might not be one machine, it may be multiple machines, right? I mean, that's the thing about any software, not just web application. Maybe the front end piece of the software that the browser need is sitting inside this machine. Maybe when the customer try to log in, right? So you saw the website and now I want to log in. So I go click here, and then click on the login button. Then I enter my email ID and password. Then most probably my browser is talking to a different machine that is dealing with the login management, right? Then maybe next time I try to place an order, I selected some item, then I am placing an order. Maybe my browser is working with an order management software. The order management software is responsible for making sure that I have the ability to place an order on the website. And then there may be payment software that runs on a different machine. So whenever I make a payment, then most probably the order management software will talk to the payment software, and basically they work together in order to achieve what they want to achieve, right? So these kind of things are expected as well. So that's the whole point. I mean, there would be, right, most of the time Amazon company, they did not develop one single piece of software. They developed many software, and those softwares are running across a bunch of servers sitting in a data center. And then from your browser, you try to establish a connection, or you try to speak to those machines, right? When I click on login button, I may be speaking to this machine. When I select the order, then I may be speaking to this machine. And when I go to the payment, maybe this machine will internally speak to the payment machines. And then, right, basically there are different software running on each of these machines, and all these machines are working together in order to serve the Amazon.in website to me. So the point is, it's not your laptop, right? These machines are sitting somewhere in the cloud. The machine have their CPU and memory. Your laptop CPU and memory will not be utilized when the software function. When you try to fetch your order history, I am curious what are the order that I placed. So I go to my order history. Then, right, it is one of these machines that are responsible for uh, finding out my order history from Amazon database, and then displaying that list inside my browser. So of course, my browser need to use some CPU and memory, no doubt about it, right? Of course, so some CPU and memory would be spent on my laptop, but the most of the CPU and memory are actually spent on this server that is sitting somewhere on the internet. So it is that particular server that is spending, not taking that is executing a bunch of program, and whatever CPU and memory those program needs would be provided by those server that where that softwares are residing. So when I say web applications, or when I say a distributed software, the distributed software run across a bunch of machines, and then each machines will be running some software, and the software get executed, and the browser request some program to get executed, then the program get executed, right? Maybe the request to execute those program comes from the browser, and then the browser execute that program, and when the program run, the CPU and memory available on the machine would be utilized for those program executions and stuff, right? So basically is the point, you remotely you browse your web application, and it will work for you, right? That's the whole point. Great. So, and it could be one single machine, right? I mean, not necessarily multiple machine. It could be one single machine that your browser is speaking with. And for every web application, it will have a front end, right? I mean, Front end is nothing but that web page what you are looking at when you browse for the website. That is basically an HTML file and some style sheets and also some images, right? Some photos such as the Amazon logo and various pictures what you see for each of these product, right? So there would be some stylish front end that you can see, and also some kind of programs that are running on your browser as well. Yes, your browser is also running certain program, and I will prove it to you. I just click this button over here, or right, maybe, yeah, I just click this button over there and you can see the whole style has changed. The background got little bit dark, and then the search box got highlighted. It was not highlighted before. Now I come out of it, the highlight is gone. So basically, as I am moving my mouse cursor or performing some operation, I can see something is happening. So it looks like some my browser is executing some program, and then that is resulting in some highlighting of the search button, or my overall window becoming darker, right? So a lot of things are happening as I move my mouse cursor, right? I just that's what happened. Or when I click, some activity happens, and it could be my browser that will take care of few of those activities. So my browser wants to run some programs as well, and those programs are JavaScript programs developed in JavaScript programming language. That is the only programming language that browser understand. So if browser want to execute a program, the program must be written in JavaScript. That is important. So, including all these things, we can call it front end of your website, right? Okay, guys, take a short break. I'm sorry, I need 5 minutes. Take a 5 minutes short break. We will continue in 5 minutes. Okay.
This conference will now be recorded.
Okay, guys, let's continue. So. Yeah, we were discussing about the web application, and the front end is all about whatever that runs on the browser. That would include that stylish website, basically, that has some style and that has some uh, design, right? Which is done in HTML and CSS, right? That make the website look good and useful to the user, and then bunch of images, logos, and stuff, right? And then a number of program that get executed based on the clicks that user make on the browser, and a bunch of the programs are executed by the browser itself, right? Such as highlighting the search button, or right, bunch of things happens based on the user activity on the browser, and that is one thing. And then similarly, there are a lot of programs that runs inside the server as well. Do you agree with me? The browser would be making a call to the server every time it wants to do something. For example, I want to place an order, right? I want to place an order, or sometimes I want to do something that right, that the browser cannot do. For example, I want to purchase a new item, I want to place an order, I want to see the order history, or I want to log in, right? So every time I want to do such kind of things, there you need to involve a machine that is sitting somewhere in the remote. So when you want to write, for example, there is a front end machine that consists of your front end software. So you just talk to that machine, and that machine will receive the request from the browser, and then it will respond to the browser with the whole front end, right? That include the web pages, that include the JavaScript programs, and right, all the front end would be served by this machine to your browser. That is how your browser get the web pages and stuff, right? And that's one thing. Then maybe there is some other machine that is dealing with the login management. So login management, when you click on the login button by providing your email ID and password, then maybe your browser might be speaking to that machine that deals with the login management. And maybe what this machine does is it will take your email ID and password, whatever you entered in the browser, and then it will compare the username and password with a database that the company already have. And if the credentials are matching, then it will set some cookies or provide some cookies to the browser. Basically, the user get logged in, right? Successfully logged in. So like that, so there would be some programs that get executed inside this machine. There are some programs that executed inside this machine. Basically, bunch of programs get executed across various machines, right? And then so these programs that run inside the machine, we can call them the backend programs, right? A bunch of backend backend programs run inside a machine that is sitting in the cloud, and they get executed based on the request coming from the browser or coming from the HTTP client. So the uses of your software are sitting here, right, in front of on the front end, and that is where they are working, and various requests that comes from the front end will be forwarded to the login management, to the front end, to the payment service, to the order management service, or various backend that your company may have developed will be dealing with all those requests coming from the browser. Or sometimes, it's not browser to server, it would be server to server communication that need to happen. One software want to talk to the other software and get yourself served and things like that, right? So this is how a web application can look like. So every web application has a front end, and every web application has a back end as well, right? The back end is developed in any programming language. It could be C or C++ or Python, or it would be Go, or it would be Java, right? It could be Ruby, it could be any programming language that backend programs, right? These are normal machines, right? These are server machines that run an operating system, and these machines are capable to run any programs, right? But the browser has a limitation. The browser can only run the JavaScript programs. That's the only programming language the browsers are capable to run. So what that means is, when you are developing your front end, right, as a company, you want to develop both front end and back end. Front end include the JavaScript program as well as the HTML, CSS, and image designs, right? And when you develop a front end in your company, you must make sure that it is developed in JavaScript programming language. That's the only programming language browser understand, right? Right. You cannot develop that in any other programming language. So for any company, JavaScript is very, very important programming language, because they must use it, right? They don't have a choice. That's the only programming language that browser understand. But when it comes to the backend, it could be any technology that you can use, Java or Python or Golang or whatever programming language that your team's favorite, or whatever programming language that works best for you. You can use them inside your backend service. These are typically the machines in AWS, or machines in Google Cloud, or machines in Azure Cloud, or it could be the machines in a data center, bare metal server inside a data center. It could be anything, but those machines are completely managed by the respective company, and they run the software into those machines, right? And that's how the customers are getting served. Great. So now the next thing, we will also talk about what is a microservice, right? Something that we will talk about. What is a microservice? So a microservice is basically nothing but another software, but developed in a more distributed way, right? It is developed in a more distributed way. So I will explain what a microservice is. Typically, when you develop a software, think about Amazon, or think about Flipkart, or Facebook, right? Any software that you use on a day-to-day basis, or any web application that you use on a day-to-day basis, and you just think from the company angle. Think from Amazon, right? How they have developed this whole software. It is a complicated software, and millions of people are using that software. So there would be lots of machine among which the software is running, right? There may be some 10,000 machines across which the entire software is running 10,000 or maybe a million machine. I mean, right? Because Amazon has a huge customer base and sometimes they want to run campaigns, and at that point, it should support too many customers at the same time. So they need to have a lot of ability. Their infrastructure or their scalability, everything should be appropriate and it should support their customer base, right? A lot of things needs to be considered. Great. Now let's talk about, now let's consider this, that we have, mhm, uh, inside a company, they are developing a software as one single piece. Right, think about Amazon started like 15 year or 20 year back, and I mean not even 20, even before that. So they started with as a bookstore, right? They started as a bookstore and they started selling books to the people by collecting the books from various stores out there in the world. And then that's how they started, and now they wanted, they noticed that the book is something uh, that they want to, right, they are becoming a leader inside in the book selling. So they started selling more and more books, and then they started partnering with more and more retailers of the books, and then they made sure that whoever places an order at Amazon for a book, they get that book, right? I mean, every books became available at Amazon, and that became one a single place where people look for whenever they wanted to buy a book. And then later on they realized that they wanted to add more and more features, so they decided to expand their business into other retail domain, and they started into other retail domains, small spaces they started to uncover, and then they realized that it has a very good potential, and then it's time to expand the business to other places, right? Maybe other states within the United States, or maybe to the other countries, right? They started expanding, and then every country has their rules and regulations that they need to satisfy. So based on the rules and regulations, they had to create a customized version of their software for each countries, and they did that. And then, right, they are expanding. The point what I'm trying to make here is that they keep on updating their software with more and more features, right? Regulation related, or the country related, or it could be the feature related, or the new feature that you are implementing. You need to keep on updating your software with more and more updates. And then the problem what happens in the background is that you started with some 10,000 lines of code, and today your software consists of billions of lines of code, and now it is your responsibility to manage all those billions of lines of code that are available in one single software. And that has become a very complicated software, right? It's not just that, you just, if you have a 10 developer, if they can manage 10,000 lines of code, then multiply by 100, you can then, increase the number of engineer, then you can manage the multiplied by 100 lines of code. That it won't work in that way. The problem is that when software become complicated, it need a lot of maintenance and management as well, which is typically the not only the work of developer but also the other team. You need too many QA engineer who want to ensure the quality of the product. You need a lot of security people because there are too many moving parts where security concerns can arise. You need a lot of operation people to manage the infrastructure. You need to scale your team, and every team size will increase abruptly. Maybe you need a team that has some 100 people in it, right? And then think about if you are working on a team that has some 50 or 60 people working in, how you will coordinate with every work that you do, right? Every time you change something, something else will break, right? The team size is a challenge, and then the number of problem that would arise every time you change the software, it can result in too many new problems, and then they are very difficult to track because most of the time you don't have a proper visibility of which functions are calling which function, because there are too many functions that have been developed from the beginning, and now you even lose the track of what function call other functions. And you may be modifying a function right now, and there may be some 10 other function which is calling this function, so you don't remember all of them, right? So these kind of problems can happen a lot when your software become more and more complicated, and it is added up with more and more features, right? So so there may be, again, you can split your entire software into three or four software small applications. Maybe Amazon will develop front end as a separate piece, back end they will develop as a separate piece, but again that will not solve the problem, right? So if you want to solve these complexities, what you should consider doing is you should split your entire software into uh, small decoupled softwares. So when I say decoupled, what that means is you can develop this software independently by a independent team. For example, you have a 5 people team, and this 5 people team can deal with a particular software. They can not only develop the software, and they are also responsible for making changes to the software, and do the testing of the software, check the security of the software, perform whatever operation that needs to be done, and finally deliver this software to the customer. So when it comes to that particular software, think about this. This is a inventory management software. So for inventory management, assume your company developed a separate piece of software. And the good thing with inventory management is that you can consider this as a different business domain within the company. Think about Amazon, think about the inventory of Amazon, think about those godowns that Amazon is maintaining and managing. Who is working on those godown? Right? The people who manages the godown, the people who take the items into the godown and take the items out from the godown, and right, they want to track the items coming in and they want to track the item going out whenever a shipping arrive, right? Basically you ordered the items in bulk from the wholesale, then the whole load, right, from the vehicle needs to be loaded into the inventory. You need some easy way to do such kind of things. There should be proper racks inside the inventory where you want to place the item. Every rack must have a number so that you can track each and every item using a computer, right? Every time you want to find an item, you just specify the item name, it will tell you which rack the item is in. So like that, you need to have a proper management of the inventory inside your inventory systems, and there would be a bunch of people, the people bringing the items on a vehicle, unloading them, then the people who sit in the inventory and tracking each and every item coming in and going out. Then there would be other people, the people who want to deliver a certain item to the customer, right? They would be coming to the inventory and taking some items out from the inventory so that they can deliver them to the customer. So those things needs to be tracked as well. So there are a few people who are interested in the inventory software. Most importantly, the shipping people, the other people are the people sitting in the inventory and the people who load products the inventory in a vehicle and things like that. So these are the people who are working very closely together, right? And they need a software that helps them all. And if you think from the other perspective, just think from the customers or Amazon. They are not interested in managing the inventory, or whenever they click a button in the browser, nothing happens in the inventory, but the order get placed on their name. That's what happens. So you can the point what I'm trying to make here is that the customer making an order is completely independent of how Amazon manages their inventory. Or maybe, right, so you have a support department who is dealing with the customer. That department is completely independent of the inventory department and the people working on the inventory. So assume your company has developed one separate software for the inventory management, then right, then the developer, you can create a small team of developer, maybe a 5 people or 4 people, a small team who will develop the inventory software. And this inventory software would be later used by the various people, that include, right, the people sitting in the inventory, the people who do the shipping, people who load the product to the inventory. So those are the kind of people who would be using this software. So basically this developer can only listens to these people, right? The developer does not need to listen to everyone at Amazon. They don't need to listen to every employee at Amazon or every department. Amazon will have some 100 or 1,000 departments, but these guys need to coordinate with only the inventory department. So they can work with these people and then understand their requirement. Maybe they need a new kind of barcode scanning, or maybe they want to insert a serial additional serial number to each product that they are loading into the inventory. So there may be some requirement that will come from them, and that will directly come to this team, and they will work on this software. They modify this software and they deliver the software to these people. So now they will see the modified version, and this whole operation can happen without interrupting any other business operation that happens at Amazon. The customer is placing the order, that they are using a different software, or the customer who are looking at the order history, or the customer who is trying to make the payment, or the support staff who is coordinating with the customer for any of their support requirement. They all work at various domain, you can say various business domain, but these people work within one business context. And then, so this is nice, right? I mean, you will love this, when, or a company will love this, having the ability to split software into these small pieces. So inventory management can be developed like this. The support management, right? The phone support management, or maybe in common you can just support management. There are a bunch of support staff who would be using this particular software. I mean, what I'm trying to say is there may be support staff who will be using this software. There would be bunch of people developing this particular software, and basically they work in a different context. They work in a different context, and a bunch of people can work independently on a separate context, and that is when you can say the softwares are decoupled. Basically, every time this team want to work on this software, they are independent of this team working on this software. Any change that happens in this software will not interrupt the other software. That team can manage this software, this team can manage this software. Rather than one single team managing a complicated software, you can split your entire applications into small microservices and decouple them as much as you can. Then you can achieve such kind of microservice based working, which is something that the companies allowed to have. So these are called microservices, and microservices can be developed independently, shipped independently, and delivered to the customer independently. And most of the time, the customer who uses the software could be different people. And then, so you just try to decouple every time you design a microservice. You try to decouple them as much as you can. It's your developer responsibility, not your responsibility. But I'm just telling you, right? This is how microservice should be developed, and they are decoupled, but they want to talk to each other. For example, you developed one microservice called shipping management and another microservice called inventory management. So this is for inventory, this is for shipping. So the shipping software is dealing with shipping the product to the customer, and at the point of shipping, the items need to be taken from the inventory, right? So every time the shipping software, right, you take out an item, or it received, it started the shipping process, it want to talk to the inventory management and tell the inventory management that, hey, I took an item from the store. So the inventory management now need to make an adjustment in their database. Let's say one product is removed from the inventory. Or similarly, whenever there is a return, one customer returned a product, then the shipping team will put the product back to the inventory. So now the inventory software need to update itself with the new product that came back. You're getting the point, right? What I'm trying to say is, even though these softwares are independent, there would be certain things they might want to talk to each other. They want to communicate about something. In one, shipping will say there's a return, or the shipping would say there's a new order, right? And then the inventory need to update with that information. So there should be a way for the software to talk to each other. And the thing is that they will not use function call to talk to each other. That is how usually software programs communicate, using some function call. But these software, if they are microservices, they talk to each other over a network by making an HTTP call, right? Or in some other method, right? They communicate over a network. Basically, one software run on one machine, other software run on other machine, and then when they want to speak to each other, they use the network, and it would be a network connection that they establish to each other, and they speak to each other through that network. So that's also important. Softwares are decoupled, and also they are connected to each other over a network, and when they want to talk to each other, they talk to each other over a network. So what that means is you are not dependent on the technology. Maybe this one is developed in Java programming language, this one is developed in Python programming language. That is okay, because softwares are completely independent of each other, and you are not going to make any function call. You would be creating some kind of a HTTP interface or some kind of a network interface which is not dependent on the technology that you used inside each microservice. So what that means is they can talk to each other, no problem, right? So it using some standard interfaces, they talk to each other, and the interface that both will understand, and they can talk to each other using HTTP or using various network protocol. They can speak to each other, but they will not make any direct function call or anything that would make them coupled, right? So they are decoupled, they won't make function calls, right? That's how they communicate each other. So such kind of software that you maintain and manage is called microservices. And many company, because of the lot of complexities that are there in today's software, right? The requirements are huge, a lot of changes are happening every day, so you don't want to complicate things by developing one single software. Most companies, even though they are using monolithic software, now they want to switch to microservices because of all this benefit that microservice has to offer. So that's the important part. And yeah, so uh, these are microservices. They are decoupled software, and they talk to each other over a network. Perfect. So now let's talk about, right, we all while discussing the web application, we also talked about the front end and back end. There will be a front end and a back end, right? And when it comes to microservice, we don't call them simply front end and back end. Rather, we call them, mini applications, mini decoupled applications, and they talk to each other over using a network, right? Is it making sense? Is it clear what we
Yes,
discussed?
please.
Great. And also make a note, the class timing is 7 a.m. this week. Please don't miss that. Class timing is 7 a.m., not 7:30. And also make sure that everyone join exactly at 7, right? So that you won't miss the important part of the sessions. All right. So now let's take a look at the workflow of a company. How do they maintain and manage, or I would say the 4-step process. So, you know, for any software, initially it is developed by the software by writing the code. So they write the code. Some coding needs to be done every time you want to develop a software. So that's what your development team do. They write the code. The developer always get a lot of requests from various people to make some change to the software, add a new feature to the software, or fix a problem in the software. So that's what they always do. They keep on working on the code. They modify the code, and that's what they do, right? And the code and softwares are different. I mean, they are actually not same. Give me a second. Hey, can you hear me?
Yes.
Yes.
Okay.
Yeah,
So
yes, yes.
the developers write the code, they modify the code, and after they change the code, every time they make a change to the code. So can I say code is same as the software? It's also called source code, but Is the source code same as the software? Is, of course. The developers are writing the programs, right? They are writing the code. Those are nothing but programs that get executed when your customer uses the software. So yes, developers are the one who is writing those programs, and they get executed when your customer do something, right? Use the software, the program get executed and stuff. That's nice, but the code or the plain text code that your developer write is not the complete software. That's because most of the time when your developer write the code, they don't not developer wants to write everything from scratch. Most of the time the developer uses some existing module or existing programs out there on the internet that is developed by somebody else, right? The developer all over the world work in a more collaborative way. Various companies, when they develop some piece of software, they make their code public so that it would become useful to everyone on the internet. And right, many companies does that, many individuals does that. So the point what I'm trying to make is that there are lot of external programs that are already available if you want to send out an email, or if you want to convert a website to a PDF document, or if you want to send out a text SMS, or from your application. When you want to do such kind of common activities, most of the time you don't have to write the code from scratch. Instead, you can make use of some existing code that is already available, already developed by somebody else. You can take that, right? Usually they are called modules or libraries, basically some external programs that you can use in your code. That's what developers do most of the time. I mean, right? They don't want to write all the code from scratch. They basically want to reuse those programs that is already developed by somebody else. That's what you want. Great. That's awesome. So the point is, when that happens, when developers start to use some external modules, then it also become your responsibility to download those modules and make sure that the code that your developer wrote plus that external code that the developer used should come together, right? Your final software need to have both, right? The source code as well as those dependencies. In common, we call them dependency. Technically we call them modules or libraries, right? Depending on the programming language and depending on various stuff. So we use those, right? Our final software not only consists of simply the code that your developer wrote, but also that external code or external modules that you are using as well. So it need to be combined together into one executable form before you can actually start using your software. So that's what companies do a lot. Basically, right? They build the software into some executable form, right? So you build the software, build executables, you can say. So you want to build some executables from the source code, because source code is not sufficient. Source code don't have everything. You want code, and the code depends on some other dependencies. And the problem is that the code depends on some dependency, and those dependencies may depend on other dependencies as well. So like that, there would be a bunch of transitive dependency, right? Assume the code depends on two dependencies, and that dependencies there depends on some other two dependencies, let's say. So like that, if you most of the time of if you consider any software, even a small software, if you consider, the number of dependency can actually be huge depending on the modules that your developers are using. So make a note of this, right? If you want your software to function, you need the code, and you need all the dependencies, and their dependencies basically the whole bunch of list you need, and you need the code, and you need to combine both of them together to create one single executable file. And that is when you can say your software is now ready to run. Till then, software is not ready to run. If you try to run the software on a laptop, or if you try to run a software on a computer in the cloud, right? Basically, first you want to create this single executable file. And one best example is that when you want to install a software on your laptop, right, you download the binary from From the so think about this, you want to install Firefox on your laptop. Firefox is a browser you might want to install on your laptop. So you go to the Mozilla website, you download the Firefox. So what you download is an exe file. So what is the advantage of the exe file? Let's say Mozilla is not giving you the exe file. Instead, the Mozilla is giving you the code that their developers have developed. Yeah, actually, that code is open source. It's available for free. You can get that code that Mozilla developers have developed in order to develop Firefox. So you can get that code yourself. You can try to run the software from the code, but it can be done. The problem is that the code depends on the some dependency. You should worry about that dependency. You should download the dependency. You need to keep them all together before you could run the software. All these complexities are there, right? So Mozilla made things easy for you. What they provide you is one single executable file. You just download that exe file. You double click and click next, 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 and you don't worry about the developer who developed Firefox, or you don't worry about the quality people or a lot of engineer who work behind developing Mozilla. You don't worry about them when you want to run Mozilla, right? You just double click next, 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 and that's it. Software got installed on your laptop. That's how the installation should happen. When you want to install a software or when you want to run a software, it should be as simple as, right, a double click, next, 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 and right, without any technical knowledge on the software, you should have the ability to run the software. That is important. That is important for every software out there. So for any company who develop the code, then installing the software is a different job. And the people who want to install software, first they need the executable files. In common, we can also call them artifacts, right? When we can call them executable, or we can call them artifacts, or some people call them builds, can also be called executable code, whatever name I say. Basically, I'm talking about that single file which you can double click and run, right? So that's what you want to do. You should build artifacts or executable file, no, whatever name that you want to call. That's what it means. It is basically the entire software in a static state, right? You double click and sorry, you double click and software would start to run. That kind of files. That's perfect. So once you have that file, then you can run that file on a computer, right? Of course, right? Maybe you have a machine in the cloud. That is where you want to deploy these files. So it could be the inventory management software that your developers are developing, or it could be the order management software, or it could be the shipping management software. Whatever software it is, you should convert that software into some executable format, so that the people who want to run the software on a machine, maybe in the cloud, in AWS, you have a machine and you want to run this executable file inside the machine. So maybe that is where you want to run your software, right? So first you want the executable file, first you need a machine, then right, then you can run that executable file on a machine. So that process is called deployment process, or basically, that is when you run the software, right? So that is part of the process. That is usually the final stage. You want to run the software, right? You want to run the software, or let's say you want to deploy the software to a machine. Usually the companies uses cloud, or right, so some infrastructure, some machines where they want to run the software at the end. That process is called deployment. So a deployment process typically means you are copying this artifact, copying this exe file to this machine. It's not your laptop usually. It could be your laptop, but usually it is a machine in the cloud, or a machine in your premise. So you should copy this executable file to this machine, and now you want to run that executable file on this machine. So this many process needs to be completed, and maybe you should also do some configuration. So there are maybe bunch of steps involved, right? Downloading the artifact, then running the application, And you should also provide some configuration, providing the configurations. So that's many bunch of work needs to be done in order to successfully run a software inside a machine, right? In your laptop, you want to install a software, you just need to click next. A lot of option you may have to choose, right? Same way, I mean, just there would be a bunch of process that needs to be done in order to run a software successfully on a computer, and that is called deployment, right? A deployment step. Perfect. So think about your company who is developing too many software. It's not only one software you are developing, but it's too many software that you are developing. So then what will happen, right? So you have inventory management software, then you have your shipping management software, then you have your order management software. So like that, you actually have too many softwares in place. That's a problem. And for each software you want to build artifacts. So looks like too many artifacts that you have to build, right? Because you have too many software, too many microservices, right? Microservice or software application, whatever you want to call, basically you want to convert their code into this executable file. So because you don't have only one software, you have too many softwares there. All right, so every software will produce a executable file. And actually, the truth is that every software produced many executable file because the code get modified by the developer in the morning. They are working on some new feature enhancement, so they have added some new feature into the inventory. These guys have added some new feature into the shipping, new feature into the order management, new feature into the shopping cart. So like that, a lot of code changes are happening. So every time the code get modified, you should create a new artifact. So yesterday's artifact is different than today's artifact. Today's artifact has some new feature that your developer have developed. So maybe you should version it, right? You should call it the inventory management 1.0.0, inventory management 1.0.1, and inventory management 1.0.1 has some new feature which this didn't have. So like that, for each software, you might want to create more than one artifacts. So too many artifact, too many project. Each project should be built into artifact, and every day you change them. You want to create a new version of that artifact, right? So like that, I'm talking about too many artifacts, too many executables coming from lot of project across your company, and right, for each project there are bunch of versions and things like that. So too many artifact that you want to maintain and manage. So how do you do that? Starting point is that you want to have, first of all, a proper storage and distribution in your company, right? There should be a proper storage and distribution. So as soon as you created the artifact, you copy those artifacts into some central storage. All those artifacts what you have, you keep them in a central storage. And then the reason why you want to keep them in a central storage is that it would become very easy to distribute these artifacts, right, in a much more easier manner. So that's very, very important. So that's what you do. You will move all those artifacts into one common registry, and then it become easy that you can distribute these artifacts across various machines, right? You have some tens of thousands of machine in your company. That is where you want to run the software. So this artifact need to be distributed across those machines, right? Your development environment, your production environment, or mini environment which you have in your company, you want to copy the softwares and put the softwares in there, right? That's again a complicated process. That's why the importance of storage and distribution. So that is another step that I want to talk about, right? I told you the four-step process, though storing and distribution is the next step that I want to talk about. Storage and distribution. because in your company there are many places you want to run these softwares. And in order to run the software, right, in order to go to the final step, first you need to have all these artifacts in a central storage so that you can download from there and run the software into the respective machine. This software will run this machine, this other software will run on other machines, or like that. You may have various machines in your company where you want to distribute and deploy the applications, right? So that's why this storage and distribution become very, very important. All right, so I'm talking about this four-step process. What is the first step? Coding, building the artifact, and then storing and distributing those artifacts using a common central storage or a registry or a repository, whatever that you want to call. And then finally do the deployment, finally run the applications into the respective machine. So this four-step process keep repeating in every project. That will never stop. As soon as your company is in operation, this process never stops, right? This process need to be repeated again and again all over, right? So developer change the code. That's what they do. They change code every time some new feature need to be added. Then you should create the artifact or the executable files, and then after that you want to store them and distribute them. Then you want to deploy them, and that is when you can see the software. You can actually start using the software only after you deployed it. So this is the four step process, and it can happen multiple times per day inside a project. For example, I mean, when I say deployment, it does not necessarily mean I am run taking the software to customer. It could also mean I am running the software on some temporary machine in your company, maybe my dev environment, so that I can preview the software. I can do some testing on the software before I take the software to. So when I say deploy, it does not necessarily mean that I am delivering the software to the customer. Deployment also means delivering software to some internal machines in your company where you can do some further examination of the software before you deliver it to the customer, right? So when I say deployment, it typically means running the software and giving you a preview. And of course you also do the deployment to production. That is when you take the software to the customer, but you don't do it multiple times a day. You may be doing it once in 2 weeks or once in 3 weeks. You will be deploying your production infrastructure. Your company may have a production infrastructure. That is where you may have bunch of right, you have a production infrastructure that consists of too many machines, and basically you want to run your software into those machines later. When I say later, maybe once in 2 weeks after you examined your software across other environment in your company. So there may be a dev environment in your company. That is where you initially deploy your software so that your internal team can see a preview and they can do further examinations. And maybe if a software is working fine in the dev environment, maybe the next thing that you might want to do is you might want to deploy the same software in a stage environment, a different environment in the company where you want to again run more advanced testing and stuff. If that's also working fine, that is when you might potentially go to the production infrastructure that is serving your customer. So that's the point. There may be too many machines, right, that your company might have. So when I say deployment, it means any of this environment get deployed. And before you deploy, you need to have an artifact, and the artifact should be stored in a central repository. And then you can deploy your software. That is when you can see the working software, the software in action, right? Until this fourth step is completed, you cannot see the software in action. You are getting the point, right? I mean, this process always repeats inside a company, never stops per day. You might want to deploy 10 times your development environment, especially the preview, right? The developer want to see a preview, the QA engineer want to see a preview of the software. For that, you want to deploy the software in some machines, which is used only internally by your company, by your QA team or dev team, the development environment or some test environment in your company. So this process repeats all the time, multiple times per day. For a project. So there are various environment, like I already told you. Inside every company, there may be a dev environment that may consist of only few machines, right? Even if you have 10 or 100 software, you can run them all in some 5 or 6 machines. That would save you some money, right? You don't need, if you want to buy them more machines, you need to have a lot of money with you. So in a dev environment, you need to have minimum number of machine. Customers are not going to use the software running on those machines. Only your internal team, your developer want to see a preview. Your QA engineer want to do some advanced testing. Your security team want to run some advanced security audits and stuff. So these machines are used for that purpose internally within your company. So this is the first place where you might want to preview your software and examine your software. And if software is working fine, then probably you will take the software to a production like environment. Probably you call it pre-production or staging, right? That is an environment where you want to run your software. Just like, the environment will look very much similar to a production environment, but actually not your customers are not using this environment. Maybe some of your customer, maybe 0.5% of your customer, or maybe 1% or 0.2% of your customer may be using this environment and directly accessing the software on this environment. But usually most of your customers are actually working with a production environment. The company may also have another environment, that is where you would finally run the software. There may be hundreds or thousands or 10,000s of machine, depending on the complexity of the software, depending on the traffic that you are receiving on your software, and depending on many other factors. You may have too many machines, and you run your software across those machines. So this is typically called a production environment. So once you uh, deploy your production environment, the last step, the deployment step. So once you deploy your production environment, that is when software finally become available to your customer. But like I said, you don't do it 10 times a day. You do it once in a week, or once in 2 weeks, or maybe once in 3 weeks, right? This is a more planned operation that you do once in a while to your company, right? So once you run your software, latest version of your software in this machine, remember, your customers are going to experience the problem. If there is a failure, right, if there's a mistake, then your customer would see those mistakes directly, because these are the machines that serve your customer. So before you take the software, you run the software here and examine, you run the software here and examine, and finally you run the software here, and that is when you deliver the software to the customer. These environments are used internally, or maybe this environment is used by some customers also. Maybe only few customer, 0.1% of your customers are using it, so that you can get some proper feedback from the customer itself before you run the software in production. So the companies will have multiple environments that they maintain and manage inside a company.